Hello everyone, my name is Santosh Gupta, and in this video series I'm going to show you some of the functionalities of the Arduino Uno, and the device we're going to demonstrate it on in this video is a light sensor. You can see that there's a blinking LED light here, and over here we have a photoresistor, and this photoresistor, it changes resistance based on how much light it's absorbing, and if we decrease the amount of light going into it, the LED pulse rate increases. And so, as mentioned, what's controlling this is the Arduino Uno. It's a microcontroller, and in recent years it's become one of the most, if not the most, popular platforms for control engineering and electronics prototyping. It's really fun stuff. And before I go on any further, I want to give credit to the Arduino website, arduino.cc. That's where I learned how to make this light sensor, and it has a lot of good stuff. You can learn a lot from it. Okay, so next let me explain all the pins in the Arduino. Over here we have digital signal. This can be used as either an inlet or outlet. Here we have analog signals. This can be only used as an inlet. The difference between analog and digital is digital, it can only go on and off. That's exactly what's going on with the LED. It's either turning on or off. And analog can give values from 0 to 1023. Depending on how much voltage is going in. 0 corresponds to 0, and 5 volts corresponds to 1023. I forgot to mention digital, even though it's just on and off, you can use it for some more intricate controls, using pulse width modulation, PWM. That's what all the numbers with the squiggly lines next to it, they can do a pulse width modulation. And what that is turning the on and off signal so fast and doing it in certain patterns that it can create more intricate controls. That's not what we're doing here, but if you want to find out more information about that, you can look up pulse width modulation on Google or Wikipedia. Also, forgot to mention, these pins are for our power supply. We have 3.3 volts, 5 volts, and V in voltage in case we want to supply our own voltage and not use either the 3.3 or 5 volts. Let's explain our device. This is the output. It has voltage going in, and that's what turns in, not voltage going in, the digital signal going in, and that's what's turning the LED on and off. And then, so this is the actuator part of our device, and this is the sensing portion of our device. I'm going to explain the circuit in more detail in my next videos, but for now I'm going to skip over this. So we pretty much explained the device and the Arduino. Now let's take a look at the program being used to control all this. I'm going to go over this line by line. So constant int LED equals 13, we're declaring a constant variable LED and we're setting that equal to 13. Int val equals 0, we're declaring a non-constant constant variable, and its initial value is 0, void setup. This is for all our initializations. In this case, we're initializing pin LED, and we're setting that equal to output. LED is 13. So what we're doing is we're setting pin 13 to send output, and as you can see, that's exactly what our Arduino is doing. It's sending output to our LED. Serial begin 9600. What this does, it opens up communication between my laptop and the Arduino. Without this command, we can only upload this program onto the Arduino, but we can't actually hear or get feedback from the Arduino. And to read what's being sent to my laptop, we can go to Tools and Serial Monitor, and this is what my laptop is reading from the Arduino. I'm going to explain what these numbers mean as we go through the program. So I just explained the initialization parts of the program, and now we're in the loop section. This executes all 6 of these programs continuously in a loop indefinitely unless we stop it. First command, val equals analog read 0. So what this does is reading signal from analog pin number A0. This 0 corresponds to A0 on the Arduino, and that's going taking signal from the sensing portion of our device. And this next command, serial print ln val, this prints the value of val, which is our input signal, and that's what we're reading in the serial monitor. So this is the signal this is the signal input into our system. Next line, digital write LED high. So what this command is doing is it's writing, it's turning on the LED, turning on 13, so it's turning on pin 13. And the next command is delay. And this command, it delays the program by a number of milliseconds by the value inside these parentheses, and so right now it's delaying the program by 736 milliseconds, or about 0.75 seconds. The next command, digital write LED low. So low stands for off, so it's turning pin 13 off, so it stops sending signals. So every time you see the LED turn off, that corresponds to this command. And then let's go delay the program for another, in this case, 0.74 seconds. So let's summarize it. It will read input, it will print it out for us to read. It will turn the LED on, wait a little bit, turn the LED off, wait a little bit, and how much we're waiting, how much the program delays, corresponds to the amount of light being read by our variable photoresistor. And so I'm just going to demonstrate again real quick. And that's it for now. I'm going to go cover a lot of these things in more detail: the circuit, the analog input, and some more programming in the Arduino, so stick around and I'll see you guys next time.